Welcome to Calculus in the AM. I'm your host, Mr. Shindelka, and we're just doing a quick review before we do the product rule. Talked about what the definition of the derivative. The description of the derivative is it's just a formula that gives you the slope of a tangent line to the original function at any point on that function. So if we have this as an example, I want to do, review our rule from yesterday, the shortcut power rule. If I said, I'll just say find the slope of the tangent line at x equals -2. Just make up, right? What we need is a formula that gives us the slope of the tangent line to this function, this quadratic function. We need the derivative. We don't need to use the limiting process any longer. We do understand it is a limit, but we found some shortcuts. That blue function, now here's one way to notate the derivative, dy by dx, or f prime of x, y prime can work too. I'll use dy by dx because I started with y. What is the slope, or what is the slope? What is the derivative of this function? Let's consider three separate problems. Using that power rule with the exponent to bring it down, multiply it in front. So he knows, someone, actually, Ali or Anmol, what is the derivative of that little expression, if you remember from yesterday? Do you remember the power rule? Shortcut? Haven't had enough practice. No. Mac, do you remember, or McKenna? You do? What is it?
It becomes 6x.
Becomes 6x. Take the old exponent, multiply it in front, 2 times 3. Reduce the exponent by 1, 6x. Likewise, then you say, well, there's plus 5x. What's the derivative of 5x? I think of it as x to the 1, because then I say 1 times 5 is 5. X to the 0, it's 1. Like it's not 0, it doesn't zero out, but x is gone, right? So 5. Then, -2. What's the derivative of any constant? 0. There's no x attached to it. If you want to think of it as an x attached to it, use that power rule, you don't have to. You can think of it as x to the 0. 0 times -2. Okay. That kind of works, but theoretically, we shouldn't even think of that. Just, it's a constant. Because the slope of the tangent line, if I only had a graph, you know, if this is x and y, and it was at -2 here, this is like all the way along, y equals -2. What is the slope of this horizontal line here? 0. The slope of any constant, if it was only that constant, is 0 everywhere. So that's why plus 0, I don't need to write that down. So now I have a derivative. And this is a formula that gives me the slope of the tangent line at any point. Hi, Miss Birchie. So, what do I do to evaluate this? I say, the slope basically is the derivative at x equals -2. Now, this notation is not as useful as f of x notation, where you say f prime of -2. I'm going to just put in, I'm plugging in -2, and I say 6 times -2, replace that, plus 5. The arithmetic ain't tough. -12 plus 5, still I'm prone to errors, -7. Now I'm double checking. Yes, it is. Okay. That's the slope. I'm sorry?
Yeah.
Okay, so if you graphed it, 3x squared plus 5x, blah, 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 and at -1, you see that it'll be a slope that's negative, -7. Kind of steep. If I wanted the actual equation of the tangent line, if I added that in here, always start with this. Y minus y1 equals mx minus x1, right? And then you plug in your ordered pair. Well, you figure out what -2 is in the original function, so you can get the y value that matches with it, right? Then you say y minus whatever that turns out to be equals m. Well, -7 times x minus -2, so x plus 2. That's where you go from there. And that's review. Okay, but before we move on, we've heard from Co-op Kleenexes, but also I need my next sponsor. And it's Surly Cow Puncher brand steel wool. Yeah, it works on the most stubborn and ornery stains and mishaps. And this is me talking here. Nothing burns my beans more than an inferior wad of steel wool. Surly Cowboy brand is guaranteed not to wither under the most intense scrubbing conditions. It's a name you can trust. Anyways. So, you guys are looking for steel wool, bypass the Bulldog, whatever. This is the stuff you want here. And it's got my guarantee here, Papa Joe, right there. Right? Anyways, back to the product rule. You guys know I'm making a fortune with this stuff. We're looking for ways to make money all kinds of ways. Now, you guys got your sheet out with product rule for you? Okay. I've color coded it. Of course, yours is black and white. Now, a product, what does this stand for? We'll quickly see. F of X times G of X. What am I talking about there? Because you won't literally see F of X, G of X too often. This is like my F of X, a function with some equation portion with X's in it. This is like my G of X, some equation portion, G of X, a function of X with X's in it, right? When we do this, well, let's take a look here. Just for sorting reasons, I'm going to rewrite this. Not that it's even, this isn't calculus, this is only strictly so that you can follow what I'm doing in this rule. So y equals 3x squared. I don't even need the front bracket on this. 2x to the 4 minus 4x. So this is strictly color-coded so that you can follow my steps. How do I apply this formula? So if you have the derivative of two things, one option is, if you're going to use that power rule, which is pretty simple, and if it's quick, I'd say the best option is to multiply this through, group like terms if necessary, in this case it wouldn't be, and then do your derivative. But if you're instructed to use the product rule, this is what you do. Other cases, the product rule is definitely quicker, so you'd use it for sure. Okay. So this says here, I take the derivative of the first thing, leave the second thing alone, g of x as is. F prime means take the derivative, right? Plus, first thing left alone, derivative of the second thing beside it. We'll go through this and see. So the derivative, I'm going to call it dy by dx, just because I got the y. If I had f of x, I'd call it f prime of x. So let's see here. I have, I'm going to match this part, right? So I'm going to do my f prime of x. The derivative of 3x squared is what I'm doing, right? That's like my f prime. Or it's like my f, sorry. So 3x squared's derivative from yesterday's rule, what is that? 6x, great. I don't need the bracket, but I'm doing it to really show that that's the first chunk. Then the rule says, leave the second thing as is. Just write it down. You gotta write it down. Oh, hey! Now, write the first thing as is, that's f of x. Do the derivative of the second thing. So what I'm going to do is write the first thing as it was, 3x squared. I could put in brackets, I don't need them. It really doesn't do anything, but you need the bracket on the second thing. Now the derivative of the second thing. So I'm doing the derivative of, well, this expression, but I'm color coding it. So that's 4 times 2, so 8x. Reduce the exponent to cube 3. subtracting 4 times 3, x now squared. So 12. Now some questions I'll say, just do the first step and leave it as is. And you'll have a hand in from me like that. Some questions I'll say, group and factor as much as possible. Let's just do a little bit of work out here. This one isn't heinous, so make it like that, but it's not incredible. Before, some people's instinct, and you could do it this way, is to multiply this through here, right off the bat. And you can, but you know what? You're going to make your numbers larger, and then do you see that you're going to end up having a factor of 3 all through here for sure, and 2 times 3, 6. You're going to have a factor of 3 all through here as well, right? You're going to end up undoing your multiplying. So if you spot it before you go through it, do you see that you can take out a factor of 3 and a letter x for both things? And those are from the front blue terms. You got a 3x. Well, let's take out a 3x. I'm going to drop the color scheme now because it's going to disintegrate here. 3x. What am I left behind with? I'm going to use square bracket because really emphasize that we've got. Well, the 6x becomes 2, right? Now, if you're a real crackerjack, you'd probably do a couple things at once. And this becomes just x. So I've got the 3x out. Now what? Yeah, it's probably time to group some like terms. This is it. I'll just tell you if you see it. I probably would have yanked out factors of 2 and 4 out of here, but I would have done this kind of in my head, and I'm not going to confuse you guys. And then I'd take a factor of 4 out of this, and then I would have put those out in front too. If you see that. But only take easy ones where you're less prone to make mistakes, so don't. So let's go with this, as mentioned. We're going to keep this as 3x, and we're going to multiply through. So 4x to the 4 minus 8x cubed plus 8x to the 4 minus 12 times, 12x cubed. Now, well, if you see a quicker way to do things, do it. I show more steps when I'm showing stuff to students. That's fun. So, we group things up. I was going to do some factoring right now, and then I won't skip steps. I'm confused. So, 4x to the 4 plus 8x to the 4. I got 12. X to the 4. Minus 8x minus 12x. Minus 20. Hey, look at that. I could pull out an x cubed out of both things, and I could pull out a factor of 4 out of both things, right? Which I spotted before. Now, there's quicker ways to do this. I'm just mentioning one, okay? Like, I'm showing the one probably with the most steps. So I'm taking out a 4, so that'll be 4 times 3 in front. That's 12. Taking out x cubed, so x times x cubed is x to the 4 in front. Dividing this by 4. 3x minus 5. We're good at this one? That's fully factored. Now what I did in black is not calculus. Everything in black is algebra, right? It's old school stuff. Now, one last thing. By the way, so when you guys know this, I got a very important thing, soup sent to me right from Campbell's. Right here. I got a message in the morning that there was a very important package that arrived in the office from somebody sent me. And it's sincerely, Campbell Soup CEO Denise Morrison. Who would have thought? Anyways, it's for real. The secretary was really giggling. I think some kids did it. I don't think it's for real. The derivative of the product of more than two functions. So if I had 3 brackets, or 4 brackets, there's 17 brackets. You could apply this rule and extend it. Now I'm not going to do 17 brackets. But if we had 3 things, I'm going to drop the f of x, g of x. I think you get it. These are all functions of x. So if you had 3 things, f, g, and h. So x plus 2, x minus 17, x plus 5, or something like that. More likely you'd use this rule, actually. In that case, I'd multiply x squared stuff with cubes and stuff. 3 things, still the derivative of the first thing, leave the others alone. Derivative of the second thing, leave the others alone. Derivative of the last thing, leave the others alone. Multiply. I'm going to sneeze, I keep feeling like that. Okay. We're going to use the product rule, though, to determine f of x in this particular case, okay? Now, I'm going to just use some underlines so that you can see this. That'll be my big blue, the first one. The second thing will be green. My red will be the 3x minus 1, okay? So we're going to apply the same principles. Just think of the product rule as derivative of the first thing, leave the others alone, plus derivative of the next thing, leave the others alone. If you have 2 things, you're done. Derivative of the next thing, leave the others alone, and so on. So use the product rule to determine f prime of -1. Okay. That's pretty straight ahead, and then there's some more versions. So the first thing, you can't just plug in -1. You've got to find f prime of x. Then, so the derivative of the first thing, 2x squared. Stop me if I make a mistake. Leave the other 2 things alone. Because I know when I make mistakes in the kitchen, the first thing I grab, surly cowpoke, steel wool. Works really good on Teflon pans too. It takes the Teflon right off. So then, that's the derivative of the first thing. Leave the others alone, right? You guys follow that? Next. Because I made a mistake, thank you. What should it be?
It should be 3x.
That's right. That's why I need you kids paying attention. If I was full of myself, I'd be saying, I make mistakes so that you guys can point them out. But no, it's, I make mistakes. X cubed now. Leave the first thing alone, derivative of the second thing. Now the derivative of the 1 in 1 minus 2x is 0. Then there's the minus sign. The derivative of minus 2x, 2x, is just 2. Right? -2. The x disappears in the sense it goes down to x to 0. Then 3x minus 1 is left alone. Plus the derivative of the last thing, leave the others alone. So I'll do it in order. X cubed. 1 minus 2x. 3x minus 1. The derivative is 3 minus 0. So 3. Now I'm stopping here for a second here. You guys good at this? There's no need to simplify this. Don't group like terms if you're not asked. I just want to evaluate. And I'll tell you the truth, you're better off evaluating from this form than trying to simplify this. So I just throw in -1 now. I want f prime of -1. Anywhere there's an x. F prime, -1. Now, you might do a lot of this math in your head. So let's just go through here. 3 times -1 squared is 3. 1 minus 2 times -1. Okay, I'm waiting. I'll play this game. So you do yours, I'll do mine. Surly Cowpuncher tells you -53 should be evaluated. There's less chance of error usually when you're doing arithmetic than if you're factoring things. So that's why you don't need to clean up that equation unless told to with the x's, right? Use a calculator if you're unsure of your arithmetic. It's usually quicker not to use a calculator, but whatever. Now, the last part of this, so we've determined this. Then find the equation of the tangent line. It's a line, so mx plus b is going to be taken. It doesn't say it has to be an mx plus b form. We'll talk about that. Through this point, -1 comma f of negative. Well, the first thing is this point, -1 comma, what's the y value? Because we need a y value to find an equation. So, what is f of -1? That is the y value of the original equation. So if I look at this, we just do this in our head, -1 cubed. Okay. So, -1. Then -1 into the y, or 1 minus 2x bracket. That should be 3, right? -1 into the 3x minus 1 bracket. That should be -4.
Why are you doing this?
Okay. So the first thing up to this line here was determine this. Then find the equation of the tangent line that passes through the point, -1 comma f of -1. So -1 is my x value, that for my ordered pair. I need the y value, which is f of -1, that matches with this. So that's what I'm doing with this. So this is the ordered pair -1 comma 12, right? So f of -1 is 12. So the ordered pair, the point is, I'm going to just write this out. I wouldn't normally. The point we're interested in is -1 comma 12. Okay. Now if I plotted that function, -1 comma 12 is a point on that function, the original f of x function before the derivative. Now we have a slope machine. It's called a derivative. Spits out slopes of tangent lines. We've already figured it out. It's -53. So then, last thing, it says, don't use y equals mx plus b as a starting point. What formula should you guys use? It's the slickest. What is it? Y minus y1 equals mx minus x1. Okay. So then, I'm going to toss this into the point slope formula. Y minus y1 equals m x minus x1. So, what I'm going to do is y minus 12 equals m. Oh, -53, because the derivative is the slope of the tangent line. Okay, you've heard this stuff. X minus -1, so actually add it. Way simpler, because all you have to do now is isolate for y. Then you've got your mx plus b as your final form. Don't use mx plus b in general, unless it's a really simple equation as your start. Add the 12 onto the other side, distribute the -53. Hmm. 41. Double check my math. Ava's 6 points for Gryffindor. She got that one error before. Now, I'll let some of you finish up to review.